Welcome to the first presentation in Unit 4. This is entitled, Are You Smarter Than a Mythbuster? So it says, shoot for the moon, and if you miss, you will be among the stars. So the learning goals are that you understand the factors that affect the range of a horizontally fired projectile, that you recognize the importance of flight time in solving multidimensional problems, and that you'll be able to solve for an unknown variable in either the horizontal or vertical direction given information from the other. So here's what we already know. We already know that the motion of an object can be described in terms of its kinematics or its motion with acceleration, displacement, final velocity, initial velocity, and time. All of these were covered in Unit 2. So if you're having a hard time trying to remember which one is which, go ahead and refer to your previous notes that you have for Unit 2. We also know that objects can move horizontally, which is left and right, and we know that objects can move vertically, which is up and down. So what we learned in the lab is that objects can move in multiple dimensions at once. We learned that if we fired a marble or something horizontally, not only does it move horizontally, but it also moves vertically as well. Now, additionally, we also learned that horizontal velocity has no effect on flight time. If you fire this marble very, very slowly, and it lands right here, it has the same flight time as if it lands right here. So we saw that there's no effect of horizontal velocity on flight time. We also saw that increasing the horizontal velocity does increase the horizontal distance. So the faster it's fired, the greater the distance that it travels will go. So what path does the projectile take? So if you were to take a look at a projectile, whenever you launch it up, it goes this way if you launch it up in the air. But if you launch it horizontally, it does this. Those are basically the same thing. If you were to look at the projectile's path from here and compare it to the point here, those are the same thing. It's both a projectile path regardless of whether or not it's fired horizontally or whether it's fired up in the air. The difference being, whenever you fire it horizontally, you only get half of the parabolic curve, but it's still considered to be a parabolic path. Flight time. Flight time is the key to solving all of our multidimensional kinematics problems. Time is the one variable. Well, we've already discovered that it doesn't depend on the horizontal velocity. But time is the one variable that is the same in both the x and the y dimensions. So because of that, it becomes the key to solving problems. Because if I can solve for the time in the x direction, the time in the x and the y direction are the same. So if you can use something from from the x dimension to solve for time and then use the time in the y, that's how you're going to solve these particular problems. Flight time is the key because it's the same in both dimensions. It's the only variable in both dimensions. So the first thing we want to do is we want to look at the horizontal velocity. For projectile motion, the way that we're looking at it, we're going to assume that there's no air resistance. And the reason why we're going to assume that is once you start to include air resistance, the calculations become particularly unwieldy. They can become very difficult, and it's almost impossible to do at this level. So because of that, we're going to assume that there is no air resistance. Well, if there is no air resistance, that means that the object is going to move at a constant horizontal velocity. So this is the only equation we will use in the x direction for projectiles. We are going to assume that it is a constant horizontal velocity, and that is the only equation you will use in the x direction. Now in the y direction, we know it's a little bit different because we know that there's always gravity that's acting on the marble or the ball. Because of that, there is always going to be an acceleration. Since there's going to be an acceleration, the vertical velocity will change throughout, and since there is an acceleration, we know that if that applies. So we'll have to choose our equation based on our other kinematics variables. Just so you know, the most common equation that's associated with projectiles would be delta D equals VIT plus 1 half a, it's 1 half a t squared. This is the most common equation that's associated with vertical velocity because generally speaking, you can measure the distance. We know the initial velocity is 0 because we're firing it horizontally. And then we know the acceleration, and that allows us to solve for the flight time. And remember, flight time is the key to all of these particular questions. So the variables, like we said, because of the way the variables are structured, we know that we're going to have a velocity in the x direction, referred to as the horizontal velocity. Okay, this horizontal velocity is going to be a constant, unchanging number. So if it's fired at 10 meters per second, then that means that's 10 meters per second. There is no initial or final in the horizontal because there is no acceleration in the horizontal. Now we're also going to have a displacement or a distance in the range. This right here is going to be called range. Range stands for how far is it going to move horizontally from its launch point. Now we also know that there's going to be a flight time, or the time the ball is moving horizontally. The time the ball is moving horizontally is the same as the time that it's moving vertically. If it takes 1 second for it to fall, it moves 1 second horizontally, and so on and so on and so on. In the vertical direction, we're going to have an initial velocity, a final velocity, a time, an acceleration, a displacement. Now, the reason why I know the initial velocity is going to be 0 is because we're going to say that the projectile is fired horizontally. Okay, if you fire something horizontally, that means you're firing it flat, left or right. Whenever you fire it flat, left or right, for the first brief instant, it's not moving up or down. So because of that, in these problems, I always know that the initial velocity is 0 in the y direction. I always know that the acceleration is negative 9.8. And then what I can do is I'm trying to figure out which one to solve for. If I have a third variable in the y direction, let's say I know the distance, that will allow me to calculate the time, and then the time I can cross over to the x-axis. It is very important that you realize that time is the only thing that crosses this line. That's why we set up our chart like this, so we say, hey, nothing crosses here except for time. So developing, we're going to put this to work. It says a rock is thrown at 20 meters per second off a cliff, landing 84 meters away. This should really say it's at 20 meters per second horizontally, because in theory, he could throw it up at an angle. But we're going to assume he throws it horizontally because that's what we're working on. And it lands 84 meters away. How tall is the cliff? So the first thing we need to do is we need to set up an x chart and a y chart. I know in the x direction, the velocity is 20 meters per second. I also know that it lands 84 meters away from the cliff, so I know that the displacement is 84 meters. In the y direction, I always know the initial velocity is 0. I always know the acceleration is negative 9.8 meters per second squared. And what I'm trying to figure out is how tall the cliff is. So I'm looking for the displacement in the y direction. Now I know a lot of people when they first start these will say, well, it landed 84 meters away, that means the cliff must be 84 meters tall. Sometimes it helps to draw a picture. You say, okay, if I throw it and it lands here, it's saying that it lands 84 meters away from the base of the cliff. So I'm trying to figure out how high this is, this height right here. Okay, so now we need to say, okay, time is the one thing that will cross between the x and the y axis. So generally speaking, I'm trying to solve for time first. And if you look, ultimately I would like to know something in the y direction. So if I can somehow solve for time in the x direction, I could cross it over and then use that time in the y direction to solve for the displacement. So we're going to go ahead and change colors real quick just to say that we're doing x. So here's x. Because it's x, there is only one equation, velocity equals displacement over time. That is the only equation we're going to use for this, for projectile motion when we talk about horizontal motion. So here you would have 20 equals 84 divided by t. You would multiply both sides by t, you would divide both sides by 20, and when you do that, you end up getting a time of roughly, well, let's write it out, 20 equals 84 divided by 20, or 84 divided by 20, which is roughly 4.05. So when you get 4.05 seconds, remember that's the horizontal time, but that time crosses over. So now I have the time in the vertical direction to be 4.05 as well. Okay, I'm going to erase just to make a little bit of room. But now we're going to go ahead and use the the y direction to solve for the height. Because remember, what I was interested in was the height of this particular thing. Now I'm going to go ahead and do it in blue just so I can specify and say that it's no longer the horizontal direction, but it's the vertical direction. And I would say I have the initial velocity, I have the acceleration, I'm looking for the displacement, I have the time. The only thing that I don't have or care about is the final velocity. So I would choose the equation that doesn't have final velocity in it, and that's delta d equals VIT plus 1/2 AT squared. Now you plug in and you would say delta d is equal to, whole term is going to zero out. The reason why the whole term zeroes out is because your initial velocity is 0. You're going to say 1/2 times negative 9.8, which is negative 4.9, and then you have t squared, and we know our time is 4.05 squared. Now, when you take this thing and you actually solve it out, you end up getting a displacement of roughly 80.4 meters. Now when you get it, it's a negative 80.4 meters, and you have to be real careful when you answer the question. So what we solve for is the displacement of the ball or the rock. So the rock fell 84 or 80.4 meters, and I want to know how tall the cliff is. So instead of saying from the top down, I want to know from the bottom to the top, which would just make it a positive 80.4 meters. Okay, in the next example, it says a plane is tasked with dropping emergency supplies to a cruise ship stranded in the Gulf of Mexico. The plane is moving horizontally with a velocity of 140 meters per second. So I'm going to go ahead and use blue for horizontal this time. At an altitude, so I'm going to go ahead and change my color and say altitude of 2,000 meters above the ocean. What horizontal distance from the cruise ship should the plane release its supplies to land on the deck of the ship? Okay, so at this point, we're trying to figure out the distance away that it should let go of its supplies so that it lands on this ship below. Now, if I were to let go of the supplies right above the ship, the supplies would continue to move in that same direction just like the plane as they fell. So what we have to do is we have to figure out, okay, how far are the supplies going to move as they fall to the deck of the ship? And once we know that distance, that's going to be our answer for this particular question. So what I'm going to do is I'm going to set up a chart of x and y's. The only thing that I know in the x direction is the velocity. I know that the velocity is 140 meters per second. And I know that I'm trying to solve for the displacement. That's ultimately what I want to know, is the displacement in the x direction. So now we look at the y direction. And when we look at the y direction, I know automatically that the initial velocity is 0. Now the reason why I know that is once again because it's moving horizontally. I also know that the acceleration is negative 9.8 meters per second squared because of gravity. And I also know that it falls, the displacement in this case, is a negative 2,000. And that is once again where you have to be careful, because the object will fall or go down 2,000 meters. Well, if you were to look here, ultimately I'm trying to solve for something in the x. And really what I need in order to solve for this thing in the x is I need to know the time. If I know the time, I'll be able to use my velocity equals displacement over time calculation, and I'll be able to solve for the answer. So what I need to do is I need to be able to solve for the time in the y direction. So I would look at my variables. I have the initial velocity, the acceleration, the displacement, and I'm trying to solve for the time. The only thing that I don't have or care about is the final velocity. So what I would do is I would use the equation delta D equals VIT plus 1 half AT squared. And I would plug in negative 2,000 equals, this term is going to zero out, minus 4.9, because that's 1 half of negative 9.8, and then t squared. I would divide both sides by negative 4.9. Now, if for some reason when you do a calculation you get this and you left it as positive 2,000, you would end up with t squared equaling a negative number. And when you try to take the square root of that, it wouldn't work. That's a hint saying, hey, you forgot something or you did something wrong. So if you're ever trying to take the square root of a negative number, backtrack and see if you can find out where you were supposed to put a negative or a positive sign. So once you cross these out, you end up solving for t, and t ends up being approximately 20.2 seconds is what it takes. So once you know that it takes about 20.2 seconds for the object to fall that far, now what you have to do is you have to plug this number in, and this value goes over here to the x direction. So now I'm going to go ahead and erase because I'm done with the y direction. Everything with the y direction is done now that I've solved for the time. So I'm going to go ahead and plug in 20.2 seconds as my time. So now with the x direction, remember it's easy. It's always velocity equals displacement over time. In this case, the velocity is going to be 140. The displacement is what I'm trying to solve for, and the time is 20.2 seconds. Multiply both sides by 20.2, and you end up getting a displacement of about 28 meters. So you should start to get the pattern of, okay, if I'm looking for something in x, a lot of the time I'll have to solve for something in y and then cross time over. Okay, so now let's look at the next example. And the next example is a mastery level question. It does involve an experimental condition that we've done before. So it says a 5 centimeter ball. So I know the diameter of this particular ball is 5 centimeters. rolls down a ramp along a flat frictionless table through a photo gate and then off the edge of the table as shown below. The table or the ball lands 1.4 meters from the edge of the table. Um, and this is the height of the table was 0. 0.8. What will be the reading on the photo gate? Okay, what will the reading on the photo gate be? So we want to know what this time will be. Now I will tell you this is a very, very important example because your teacher may decide to give you some sort of performance test on whether or not you can place a cup at the right location to have a ball land in it. So mastering these calculations is going to be very important. So in this case, what I'm really trying to figure out is I want to know the time. Whenever I figure out the time, it's going to be calculated by this. Velocity, the velocity of this particular ball, is going to be equal to the diameter. The diameter of the marble is 0.05 meters or 5 centimeters, divided by the time. And this is ultimately what I want to solve for. So I'm going to star that just so I know what I'm looking for. In order to solve for that, I'm going to have to solve for the velocity. And this velocity represents the horizontal velocity. So the ultimate goal is to solve for the time, but in between, I'm going to have to solve for the velocity. Okay, so we're going to go ahead and look, and we're going to say, okay, I have in the x direction and in the y direction. In the x direction, I have 1.4 meters is the displacement. In the y direction, I have the displacement, go ahead and say delta d, is 0.8 meters, but it should be negative because remember the ball is falling that distance. I always know the initial velocity is 0. I always know the acceleration is negative 9.8 meters per second squared. So if you were to look, I have sufficient amount of information to use delta D equals VIT plus 1/2 AT squared because I have the displacement, I have the initial velocity, and I have the acceleration. When I plug in, you get something like negative 0.8 equals, this term zeroes out, minus 4.9 t squared. You can go ahead and you can solve for the time that it takes in this particular case. And when you do that, you end up getting a very, very, very small number of 0.404 seconds. You divide both sides by negative 4.9, take the square root, and you end up with 0.404 seconds. Now here's where it gets tricky for some people. You are trying to solve for the velocity, okay? You are trying to solve for the velocity of this marble. People say, well, no, I have the time. I can just take it and plug it in here. Remember, there are two different times. This 0.404 seconds is the time that it takes that the ball is traveling here. This time right here is the time that it takes to pass through that photo gate. Those are two different things. So basically, we have velocity in the x direction is going to equal the diameter of the marble divided by the time of the photo gate, but that's also going to equal the horizontal distance divided by the time in the air. So you have basically two things that velocity equals. So what I'm going to do is I'm just going to set them equal to each other because I'm not really that interested in velocity. So the distance that the ball travels in the air is 1.4 meters. The time that it's in the air is 0.404 seconds. The diameter of the marble is 0.05, and that allows me to solve for the time of the photo gate. At this point, you would just cross multiply and divide, and whenever you do that, you would get a very, very small time. The time of the photo gate ends up being 0.014 seconds. Now, you may be asked to do something similar in which you take this measurement, okay? You take the diameter of the marble. That allows you to calculate the velocity in the x direction. You can measure the height of the table. That would allow you to solve for the time. Once you have these two things, you can calculate this horizontal displacement, put a cup there, and the ball should